Hi students, in last video we observed the arithmetic progression, right? What is arithmetic progression and how to find the nth term of an arithmetic progression and how to find the sum to n terms of an AP, right? And now in this video we are going to solve some problems related to this AP, okay? Let us solve the first question. The question goes like this. What is the sum of all positive integers up to 1000 which are divisible by 5 and are not divisible by 2? Here, sum of all positive integers up to 1000, no doubt they are asking. But there are two conditions here. Okay. Whatever the number you are taking which are divisible by 5, those can be divisible by 5, but they do not divisible by 2. Okay, they they cannot be divisible by 2, right? So for that, let us take sum of all positive integers up to 1000 which are divisible by 5. I am taking. So sum of all positive integer which are, if the numbers divisible by 5, if the numbers divisible by 5 means, what are the numbers? Can you guess? Yeah, no doubt. Those are nothing but multiples of 5, right? Yeah, 5, 10, 15, 20, so on, up to how much? Up to 1000, they said. So up to 1000 you are getting. But what about the other condition here? And this is very important. So these are the two conditions combined for the question. Okay. And are not divisible by 2. So this is our series actually when you take the problem up to this, right? Before and. Now, if you consider the next phrase or next part of the question, what happens? Here we can observe which are not divisible by 2. Which are not divisible by 2 means, so we have to erase this. So this can be out, this can be out. And the final thing, 10, 20, 25, 30, right? So 30 also, 40, so on like this. So these are going to be removed, right? So here, if you observe the last term, so like this you are getting, so 1000 is our last term when you compare, when you take the first part. But when you go for the second part, which are not divisible by 2, so this is also not comes in our series, right? So what will be the before number? It should be 995. Yes. Okay. So now we got the other sequence or progression. Come on, what is that progression? Can we take 5, 15, okay, and then 20 gone, no? 25, next 35, so on, 995. So this is our sequence or progression. What are they asking? They are asking sum of all positive integers. So we have to take sum of these, right? Yeah. In order to sum of these, what do we know? We know how to find the sum to n terms of an AP. What is sum to n terms of an AP? Sn is equal to n by 2 upon n by 2 into 2a plus n minus 1 into d. Yes? Or you can another way, you can write this as n by 2 into a plus l. Why? Because the last term we are assuming it as a plus n minus 1 into d. Here 1a. Okay, a plus l you are getting. Right? So this is our formula. Now you know here the first term, that is a, you know, and the last term also you got. Okay. Now First term you know, last term you know, and sum to integers they are asking, that we don't know, and we must know n, right? In order to get the value of n, you observe this progression. Can you easily calculate Tn by observing this? Yeah. Let me calculate. First, I will erase this. Then I will go with this. Okay. Yeah. Now, here A is equal to 5. Okay. And D is equal to 15 minus 5, which is equal to 10. Okay. A is equal to 5 and D is equal to 10. So, can you find Tn now? Tn is equal to A plus n minus 1 into D. Okay. So Tn here, what is Tn? Tn you know already. 995 is equal to A is how much? Sorry, 5. This is 5. 5 plus n minus 1. We don't know n, right? How many terms? Number of terms. That is n. We don't know, right? But Tn is nth term. N is number of terms. Okay. N minus 1 into D is 10. Okay. 995 is equal to 5 plus, you multiply with 10, then what do we get? 10 only. Okay. 995. So 5 minus 10 becomes minus 5. If you send this side, it is going to be positive 5. Okay. So what do we get? 1000 is equal to 10n, and n is equal to 1000 upon 10, which is 100. Yes, we got the n value. Now we can easily calculate. So n is equal to 100. If you know n, we can easily calculate Sn. No? Come on, let us calculate. Sn is equal to n by n upon 2 into a plus l. Okay. What do we get? N is here 100. 100 by 2 into A is, so we are considering the sum series, right? 5 plus 15 plus 25 plus 35 plus so on 995. Okay. Sum to n terms. That is Sn. Okay. So how many terms? We already got the same sequence or the same progression we took. So we got n as 100. Okay. Now, what do we get? 100 upon 2 into A. A is 5 plus L is 995. Yes. What do we get now? We are getting 995 plus 5. How much? That is 1000. Okay. So 2 one time, 2, 5 and 2 zeros. So how much you'll get? 5 after 4 zeros. Right. So how much? 50,000. So 50,000 is the sum of n terms of sum of all positive integers up to 1000, which are divisible by 2 but not divisible by 2, and are not divisible by 2. Yes. Let us move to the next part of the AP. What is the next part of the AP means? You observe, we know that same. Let me take A, comma, A, B, C. Let me take the three terms. These are in AP. Okay. If those are in AP, how do you identify the given numbers are in AP or given terms are in AP? That is, the common difference is same. If the common difference is same, then you can say that those two are in AP. That means B minus A is equal to C minus B. If if the condition is, if this condition is satisfied, then you can say that ABC are in AP, right? So I want to calculate arithmetic mean. How do we calculate arithmetic mean for the given three terms of AP? So In order to calculate the arithmetic mean of the given terms, if ABC should be in AP, that is important, okay? So B is equal to just mean of the remaining two, okay? So arithmetic mean, middle term mean is equal to B is equal to A plus C upon 2, okay? And now, in the same way, if you observe, say A1, A2, A3, AN or in AP, let me take like that. What I am taking? A1, A2, A3, so on, AN, comma, B. Say, before that you take A also here, B or in AP. Then what happens? Here A1, A2, A3, AN are called N arithmetic means, right? So whatever the numbers which are present between the first term and the last term are called those arithmetic means. Here how many arithmetic means? N, because nth term, right? This is the nth term. That's why we are having N arithmetic means, right? So arithmetic mean, AM, it can be called as, okay? Yes. So if you have N arithmetic means between A and B, then common difference always B minus A. So you take this difference, B minus A by number of terms plus 1. This is our common difference when there are N arithmetic means between A and B. Correct? So D is equal to B minus A by N plus 1. If you observe sum to N terms between A and B, sum to N terms between A and B, how do you find? So this is simple n by 2 into A plus B. Okay, n by 2 into A plus B. So what is, how do you calculate arithmetic mean? B is equal to, if ABC are in AP, B is equal to A plus C by 2. Okay, n arithmetic means between A and B, you can say that middle term is equal to sum of the remaining two terms divided by 2. Got it? Yeah. Let me do one more one question depending upon this arithmetic mean. Okay. Yeah. Same. They are asking insert 5 arithmetic mean between 4 and 22. Okay. You are inserting, this is 4 and the last number is 22. You are inserting between them A1, A2, A3, so on, AN. What is N arithmetic means between N? Let N arithmetic means N. Here, how many they are asking? Only 5. So we have to insert only 5 arithmetic means. So can you consider 5? Let A1, A2, A3, A4, A5. Right? A5 be the arithmetic means AN. Arithmetic means between 4 and 22. Okay. Then you can easily between 4 and 22 means this is our progression, right? This is our progression or not? A1, A2, A3, A4, A5. Okay. Otherwise, you do one thing. So A1, A2, A3, A5 you have to insert, right? 4 first one and the next one is 22, right? The last one. Now you are inserting the 4 arithmetic means you know here A is 4, correct? Mm. Do you know D? We don't know t, right? And what will be this term? So if you insert n arithmetic means the term, the last term should be n plus 2th term. Why? Because you are here writing first term also. Okay, not only these terms. You are writing this a first term also. Yes or no? First term also. So whenever you insert 5 arithmetic means between 4 and 22, then this 22 term becomes 5 plus 2. That is 7th term. Yes or no? You observe 1, 2, 3, 4, 5, 6, 7. Right? So this becomes the T7th term. Can I find 7th term? So T7 is equal to 22. You know how to find T7. T7 is equal to A plus 7 minus 1 into T. Okay. A plus 60. A plus 60 is equal to 22. Then A is how much? A here 4, right? 4 plus 60 is equal to 22. Okay. So 6D is equal to 22 minus 4. So 6D is equal to 22 minus 4 is 18. D is equal to 18 upon 6, which is equal to 3. Okay. We got D as 3. So we can easily write the remaining terms, right? A1, A2, A3, A4, A5. Easily write. How do we write? Come on. Let us write the remaining terms. So A1 is nothing but A. A1 is nothing but A plus B, right? So A plus B, that is 4 plus 3, which is equal to 7. Okay. So T7 is 22. That's why you are getting 7 is the first term. Second term is A plus 2D. 2 3s are 2 3 times 6. Next A plus 3D. 4 plus 3 into D. What is D? D is 3, which is 9 plus 4, 13. Next A plus 4D. 4 plus 4 into 3. A plus 5D. 5 into 3. A plus 5 into D. D is 3. So 4 plus 15, which is equal to 19. Okay. So what are the terms we got now? 7, 10, 13, 16, and 19. These are the terms we are inserting between 4 and what is the other one? 22. 5 arithmetic means which are to be inserted between 4 and 22. In this way, we can easily calculate arithmetic mean. So arithmetic mean, what is arithmetic progression? How do you calculate arithmetic in AP, TN, and then SN, all the things, okay? And some important points related to this AP are, if you take, I am taking Tm is equal to 1 by n, okay? That is mth term is 1 by n, nth term is 1 by n. Okay, if you take like that, what do we get? Tmn. Tmnth term is always 1. Tmnth term is always 1. And Dmn is equal to 1. Okay, and Smn is equal to half into mn plus 1. Understood? And what about So D we got SMN, TM and A also. A is equal to 1 by MN. Yes. Okay. Next important point is if you take Tn as one group and Tn dash is another group, then if you take the ratio An plus B by Cn plus D, so An plus B by Cn plus D means those two are different, right? Okay. So Sn is equal to Sn is equal to Sn is equal to A into N plus 1 by 2 1 by 2 plus B by C into N plus 1 by 2 plus D. That means if Tn by Tn dash is equal to Ax plus B by Cx plus D, then Sn is equal to A times N plus 1 by 2 plus B, C times N plus 1 by 2 plus D. Okay. These are the important points you remember. And some more three formulae which are related to APR. Let me tell you. 1 plus 2 plus 3 so on. So these are all natural numbers, right? If you go on adding like this up to n terms, what do you get? So you know, you can observe 1, 2, 3 so on, right? Up to n terms. What do you observe? Sigma. This can be called as sigma because we are adding all the numbers. That's why it can be denoted by the letter sigma, sigma n. Okay, sigma n is equal to n into n plus 1 by 2. అదేవిధంగా in the same way, sigma n square is equal to n into n plus 1 into 2n plus 1 by 6. Okay, next, sigma n cube is equal to sigma n whole square. Okay. Say sigma n square means, what is sigma n square? That means 1 square plus 2 square plus 3 square. If you take this kind of arithmetic progression like this, then what will be the sigma n square? N into n plus 1 into 2n plus 1 by 6. Sigma n cube in the same way, 1 cube plus 2 cube plus 3 cube, so on like that. Okay, sigma n cube is equal to 2n whole square. Sorry, sigma n whole square. Sigma n is n into n plus 1 by 2 per whole square. This is very important. By 2 whole square. Okay. So sigma n cube, sigma n square, sigma n cube. Like this, we can write easy way by using sigma. So if you, what is Sn? Sn is nothing but sum of terms of all the things up to n terms, right? Sigma Tn is nothing but Sn. Okay. Next, sigma 1 is equal to what? N. Right? Sigma 1 is equal to n. And then next, sigma n cube is equal to sigma n whole square, you know. Sometimes they may ask the problems like this. If three terms are in AB, then their sum and product are given. They are asking us to calculate their sum. Or, okay, at that time, three, if you take three or odd number of terms, if you see, then A minus D, A plus D are the three terms. Okay. And similarly, if you go for four terms, A minus 3D, A minus D, A plus D, A plus D, A plus 3D. Okay. These are the four numbers. Like this, we are going to take three or four terms again. So we observed in this video, in the previous and this video combinedly, we observe what is general series a plus d plus a plus 2d plus a plus n minus 1 to d, right? And first term of general series is a, and the last term is d. Last term is l, okay? And d is the middle term. Sorry, d is the common difference. D is the common difference, okay? And nth term is Tn is equal to a plus n minus 1 into d. And sum to first terms is equal to n by 2 into 2a plus n minus 1 into d. If you simplify that, you are getting 2n into Tn is equal to a plus n minus 1 into d. Okay? Like this we can write. And we know next, after that, if d is equal to, let us take, you have Sn. One important point I'm saying. Sn you know, and Sn minus 1 you know. Then how do you calculate Tn? Tn is nothing but the sum of Sn minus 1 and Sn, right? So the difference, sorry, not sum, difference. Sn minus 1. If you take the difference between the two sums, like starting from n terms and coming from and subtracting from Sn minus 1, you are getting En. Okay, got it? Yes. I am going to end the session today. So in next video, we are going to observe CP. Okay, what is geometric progression? What is geometric mean? What is GP, geometric progression? Useful in daily life. All the things we will observe in next video.